All right, so we are ready to look at the last quantum number that is going to give us the specific properties of the orbitals where the electrons are found. And so this last one is known as the magnetic quantum number. And the magnetic quantum number tells us the orientation of those orbitals in space. And we really looked at that in our last video where we looked at the axes that P, D, and F lie along. And then the symbols that we use for that is M. All right, so what I want to try to do is summarize relationships that we should know about our quantum numbers. And again, I want to relate things back to our periodic table. So let's start with, I know there are 7 energy levels, but again, we're just going to focus on, for now, on our quantum discussion, the first 4 energy levels. That way we are not talking about hypothetical sublevels. Okay. All right. Now, we know if we know the value for n, which is the energy level, then we know how many sublevels there can be. So if n is equal to 1, there's 1 sublevel, and it is called 1s. I know that if I'm in the second energy level, the lowest number of sublevels there can be is 2, and there would be a 2s and a 2p. If I'm in the third energy level, there would be 3 sublevels. There would be a 3s, a 3p, and a 3d. And if I'm in the fourth energy level, there can be 4 sublevels allowed. There would be 4s, 4p, 4d, and 4f. All right. If I take the energy levels and I square it, this would actually give me the number of orbitals. Right? So 1 squared is 1. Okay? And if we think back to our angular momentum quantum number, remember that S only has 1 orbital. If I take 2 squared, I get 4. So here's how we get that 4. We have the 1 orbital in 2s, and remember that p has 3, and so that's where the 4 comes from. If I take 3 and square it, we get 9. So again, here's how I get that. The 1 in 3s, the 3 in 3p, and if we go back and look at our notes on the angular momentum quantum number, d has 5. If I take 4 and I square it, I get 16. So again, 1 in s, 3 in p, 5 in d, and f has 7. All right, so now the new relationship we need to talk about is electrons. So here's what we need to know, that 1 orbital can only hold 2 electrons. Okay. So when I'm filling in this table, this would be the maximum number of electrons I could have in that orbital or in that energy level. So if I take the orbitals and I multiply it by 2, that means the first energy level can have 2 electrons. If I take the second energy level and multiply by 2, so 4 times 2 means there can be 8 electrons. If I take the orbitals in the third energy level and multiply by 2, so 2 times 9 would be 18. And if I take the 16 orbitals in F and multiply by 2, that means F can hold a total of 32 electrons. All right, so if you would want to pull out your periodic table again, let's relate all of this to the periodic table. All right, now again, you may want to write directly on your periodic table. So the periodic table, when we get to chapter 5 and we're going to look at the properties of elements on the periodic table, the way the properties are divided up is that they're divided by blocks. And the blocks of the periodic table are labeled by what sublevel is being filled by the electrons in that element. Okay, so we know that there are the energy levels because we've already numbered these. Those were our periods. So we had 1, 2, 3, 4, 5, 6, and 7. Now we're going to use the groups. Those are the vertical columns on the periodic table, and the groups are going to represent our blocks. So these first two groups of the periodic table along with our friend helium over here on the other side, these are referred to as S block elements. So that means when we write their electron configuration, the last sublevel you should be filling should be the row they're in, which would be the energy level, and the block they're in tells you the sublevel. So that should be the last part of your electron configuration. All right, then we're going to go to the other side of the periodic table here. And so on this side, there are 10 columns, not 10, there are 6 columns on the periodic table. And these 6 columns on the periodic table, again, not including helium because we already said he's an S block, these are the P block of the periodic table. So some of my students in the past have actually colored in their periodic table to use when they're practicing electron configuration. Obviously, it's not the periodic table you're going to get for the test, so things to keep in mind. Okay, then this middle section of your periodic table, which would be groups 3 through 12, so this part of the periodic table is referred to as your D block. And then finally, there's a part of the periodic table. Now, these two series actually are part of the 6th and 7th row of the periodic table. These are your F block elements. All right, so again, it's all about patterns. So here's what we know. If I have an S orbital, S can hold a maximum of 2 electrons. Notice that there are 2 groups of the periodic table. So 2 is the key here that make up the S block. If I'm talking about the P sublevel, P has 3 orbitals. The orbitals hold 2 electrons. So P can hold a maximum of 6 electrons. Okay. And if I look, there are 6 groups on the periodic table. If I'm in the D sublevel, D has 5 orbitals, and if each orbital can hold 2 electrons, D can hold a total of 10. And so if I look, there are 10 groups in this section of the periodic table. And then finally, if we're talking about the F block, we're talking about the F sublevel. It has 7 orbitals, and each orbital can hold 2 electrons. So F can actually hold a total of 14 electrons. And if you count the elements in these series, there are 14 of them. All right, so kind of a review. S block, we're referring to electrons, the outermost electrons being in the S sublevel. We know S holds 1 electron, 1 orbital, and that 1 orbital can hold 2 electrons. If we're talking about P block, we're referring to the outermost electrons being in the P sublevel. We know that P has 3 orbitals, and if each orbital holds 2 electrons, this can hold a maximum of 6 electrons. If we're talking about D block, we're referring to the D sublevel. This has 5 orbitals, which means you can hold 10 electrons in D. And if we're talking about the F block, we're referring to the F sublevel, which has 7 orbitals, and it means it can hold 14 electrons. Okay, so not only should you be able to see relationships for energy level, but relationships for the sublevel also.